Hello folks, welcome to the Age of Asparagus and the third part of phase 2 of making a 3D top-down shooter in Godot. By the end of this video we'll be able to set a foreground color and a background color and have the obstacles colored on a gradient between them. At first we'll do this the easy way by applying a new material to each object based on its position, and then I'll show you how to do the same thing with a simple shader. So let's go to our script and we're going to add a couple more exported variables here. Let's export, and we're going to export a color, and this will give us a nice little color picker in the inspector. So we'll have a foreground color, and let's export a background color. We will need set gets for this because when we change the color we want to regenerate the map. So let's set back color, and up here we'll set the fore color. It'd be nice if there was an editor had a shortcut here to generate these, eh? Set back color. Background color equals new val. Good. And then regenerate the map. And now we'll set the fore color. Okay, so if we go to our map inspector, we should see the color pickers, which is cool. So we can choose a couple different colors that we want to make our obstacles. So let's go back to the script and actually use this somewhere. So to generate our material, we're going to need to know its Z position. Here, I'm going to reorient that. Its Z position, its depth, right? So if we hit 7 in top-down view, this would have in our map chords array, this is going to have this row will have a Z value of 0, and this row will have a Z value of whatever the map depth is, right? In this case, 11. 0, 1, 2, up to 11. Up to 10, actually. So let's go back to the script, and we're going to need to know the Z value. So we'll have to do it after we know the obstacle's position, create a new obstacle, we set the height. Why don't we go... So in here, we're going to create a new material and set its color. Okay, so let's just create a new material as a variable. New material, and we'll infer the type here. Let's do a new spatial material, and let's instantiate that. Then we're going to set the new material's albedo color. And this is where we're going to have to do some calculation about what that color is based on the depth. So we'll go get color at depth. We're just going to create this method, and we'll pass it the Z value. And after we do that, we'll actually set the new obstacles material. Dot material, and we'll set it to this new material that we've created. Okay, so let's create that new method now. Get color at depth. We're going to get the Z value. And for now, let's just try returning some color, aquamarine, to see if it's working. Okay, did everything go aquamarine? It did! Okay, so at least that's working. So now instead of this, what we want to do is we want to get some gradient between the foreground and background color. So we can do that because colors have an interpolation available to them. So let's start with the background color, and we should be able to pull up a linear. No. It's not auto-completing for me, which has me sketchy about my static typing somewhere here. Everything looks good. Do you need me to? Maybe because I don't give it a default value, it's not inferring the type. I thought it would because of this. So let's try that. Error? No, okay. So here, what about now? Maybe. There we go, linear interpolate. Okay. So what we can do, if we hit Alt F1, Control F1, color linear interpolate, returns the linear interpolation with another color, where the interpolation factor T is between 0 and 1. Okay, so it's going to go from the current color to some target color with this ratio here, with this interpolation factor. Okay, so we want to go from the background color to the foreground color, which will be our first parameter, and then we need a number between 0 and 1. So when z equals 0, it will be 0, and when z equals the full map depth, we want it to be equal to 1, right? So if we just did this, it's probably just going to be the background color everywhere except for the first two, because here it's 0, here it's 1, or maybe just less than 1, and then the rest are all greater than 1. So we need to kind of normalize this by dividing by the depth of the map. Divided by map depth. Why is my autocomplete being sad? Did that work? So background color, linear interpolate, foreground color, z divided by map depth. Now it's all blue, which is what? Our background color. Okay, so z is an integer, map depth is an integer, so it's casting, z is an integer, map depth is an integer, so it's the resulting value of this expression is going to be an integer, so we don't want that. Let's go float z, and then so hopefully when we tell it cast z to a float and then divide by an integer, it'll leave it as a float. Hey, look at that! So cool! Okay, and so we should be able to change this color, and it's updating it live because every time that set function is called, it regenerates the map. That's neat, eh? Oh, that's fun. So I thought it would be cool to try creating the same effect with a shader. I've never dabbled in Godot shaders before, and I thought, hey, what could be more simple than this? Well, I was wrong. For whatever reason, I found it really hard to figure out how to even get started with shaders. Because of that, I decided to pull out some of the content and put it in its own tutorial, a gentle introduction to Godot's spatial shaders. And I'll throw a card up and a link in the description. We'll be taking the shader we make in that video and using it here. So you should pause this video and go work through that one if you haven't already. If you're not interested in doing that, then you can also just download the shader material from the video description and carry on. Okay, by now, whether you've created it from scratch or you downloaded it, you should have the shader material somewhere on your computer. This is the location of my Godot project. I'm going to go into the 3D game and in the level folder, and let's put it in the level generator, and I'll drag it over here. And once I've dragged it over, I can close these and I can go back into Godot. Let's open the obstacle scene. And over in the inspector, with the CSG box selected, let's drag this shader material. I called it FG shader material. I was thinking foreground background, but I forgot the background part. So let's drag it over here. We'll plop that material on, and we're getting what we would expect, right? Everything, it's going between a foreground and background color. If we click the material here, and then we click the visual shader, we should see our shader parameters here, and the shader that we built. Okay, let's save this and we'll go back to our level generator. So the level generator scene, I'm going to open it up here. And this is our scene as we made it before by generating the material for each block. So in the output here, let's go back to the map. And now we need to modify our level generator script so that it does not replace the new shader material we applied to the ground. In fact, we shouldn't need to do really anything now in our level generator script with material. So let's go down to where we add the obstacles, and below that we create obstacles, and instead of creating a new material here, I'm just going to Control K all the material stuff out. So now it should use the ground shader material that we applied to it. Let's take a look at what this looks like in 3D, and there we go, we got it. At least we got what we want only within 0 and 1 on the z-axis. Because do you remember, we never actually scaled the shader to take into account the actual depth of our level. Right now it only works between 0 and 1. Okay, so let's do the one modification we're going to do here to our shader, and that's we're going to take into account the depth of the level. So let's go to our, double click our shader material here. We can open it up, and I'm going to increase the size of this section here, And really I'm interested in the Z direction, so I'm going to turn it this way. In fact, I'm just going to hit 3 there, because that'll show us exactly what we're going for. Oops, I keep trying to scroll to zoom in here, but Shift or Control scroll wheel do not work. I'm going to hit the plus here. Middle click to pan. So in case you downloaded, which I hope you just built it from scratch following my other video, but if you didn't, here in the vertex processor, we're converting the vertex input into global coordinates by multiplying it by the world matrix, and we're going to send it to the fragment shader, the fragment processor, through this color vector here. So the color vector is we're going to use that as an input in our fragment shader, and that's going to be the global position of each vertex. We're going to only take the Z value of that vertex. I'm going to move this over a little bit. We're taking the Z value and we're using that as the interpolation value between a foreground color and a background color, and we've set these to color uniform so they show up in our inspector over here. And this is going to scale those two colors based on the value of Z, which currently, although it could go from, say, this would be 11, although it's going from -11 to +11, when you're mixing colors, the weight here is looking for a value from 0 to 1. I don't like these lines crossing here, so let's put the background color there and the foreground color here. So what we need to do then is we need to do some work between the Z value and the weight. So the Z value coming out is going to be a value from, in this case, -11 to +11, which is the depth of our level, 22, or probably the depth of our level is 11 because each block in our depth has a size of 2. So we need to convert that into a weight value from 0 to 1. The first thing we can do, obviously, is we could just divide by the actual depth of our level. So let's do that. Let's add a division. And this is just a scalar division, pretty easy, right here. So we'll divide the depth of our level by some value, and let's just start by, we know the level is 22, I think, so let's try putting that in. Seems to be working a little bit, but what's actually happening is now it's going from 0 here, and it's scaling the 1 value all the way up to 22, but only in the positive direction. So out here, it would probably be red. So let's actually just try 11 here. And we should get exactly what we want, but only on half the level. So not only do we need to go, so when we divide this by 22, divided by 22, this becomes 1, and this becomes 0. So now we have a scaling from 0 to 1. But what we want, this to be 0, and this to be 1. So what we'll do is we'll just add 0.5. So this whole thing will shift up and end up having blue here and red here. So we're shifting like that. Hopefully that made sense. So let's now add 0.5. And we should get what we want. There we go. So we have blue there and red there. Beauty. Okay. Now, problem is, I've hard-coded 22 in here, but the whole point of this is so we can change the level easily. So let's move this over here, and we're going to add a new uniform, like an export. Except this time it's just going to be a scalar uniform. And this is just going to be a value. And we'll call this the level depth. And over here, if we put 22, we should get the effect we want. That looks good. However, I did want discrete color differences. I don't want the color to actually change in the obstacles themselves. I want this row to be one color and then a little discrete change to the next row. So it's not just like a gradient, instead it's discrete steps. So we're going to have to add just a little bit more to our nodes here. And how we can do that is if I focus here on one obstacle. Let's use this one here. So we see a little bit of a gradient here, and that's because this vertex has a different depth than this vertex. So the color you would expect to be different. So instead what we actually want is we don't want to change the color based on the individual vertices. We want to change the color based on the origin of the object, somewhere in the middle there. So what we need to do is somehow, instead of taking, so if you can imagine the origins there, we have, say, this point, instead of using this vector, this, XYZ value and converting it to an RGB value. We actually need, for each vertex in the object, we need to get this vector, the origin of the object itself. And that should provide the same color, the same XYZ value, and thus the same RGB value to each vertex in the object. So if we go back to our vertex fragment here and look at our global position, the global vector of each vertex. So something in here we need to do to convert that local position into a global position for each vertex. So regardless of whether it was there, or there, or there, or one of the ones on the bottom, they're all going to give us this value, the origin of this cube. So you can't actually get any information about the rest of your scene in a shader, at least not directly. Like I can't get the object's origin. So we're going to have to do a little trickery in order to calculate it. And how we can do that is, if you imagine this is one of our cubes, and from this vertex we want to be able to get the global position, is we can take the local position of a vertex, say this one, and the global position of the vertex, which we've already calculated here. And if we subtract the local position from the global position, we'll end up with the origin of the object. For whatever reason, I do not find subtracting vectors intuitive the way I find adding vectors intuitive. It doesn't seem obvious to me. However, if you just think of subtracting vectors as adding the negative of a vector, it becomes way easier for me to conceptualize in my brain. So let's just do that. So we're going to take the global vector and we're going to add the negative of the local vector, and that will give us the object's origin. And that will be true regardless of which vertex we're trying to get. So let's do that. Let's find a vector subtraction. There's the scalar, here's a vector subtraction. So we are going to take the global position, which is what we have coming out of this, and we're going to subtract, or add the negative, of the local position, which is this one. And if we now use this as our color input, you should notice a difference. We now have discrete colors. So take a look at the difference between that. Maybe if I go into side view, it's easier to see. Oh yeah, that's way easier to see. So here you can see it's just a smooth gradient, whereas here, boom, we have discrete colors that you can see a transition of. And that's what I want. Okay, we need to go back to the fragment now. Let's click on the shader here so we can get our shader parameters. So we don't want to have to go into the shader to edit the shader parameters. We want to be able to do that right on our level, and we want to use these. So if I change these, it actually propagates that information to our shader. So this is where we get to do some scripting. Okay, let's create a new variable called shader material. And this is just going to temporarily hold our shader material. Whoopsie. Shader material variable. And we're going to use that when we generate a map down here. After we add the ground, we'll create a new method called update obstacle material. And let's add this after we add the ground here. Kind of keep it in order. So let's start by creating a temporary obstacle so that we can get its material. This is a CSG box, we know, and we're going to go obstacle scene dot instance. So we're just going to be doing this once when we generate the level, and we'll get the shader material from it. So from our temp obstacle, we're going to get the material, and we'll do it as a shader material. So we'll cast it to a shader material here, and now we're going to set some of those uniform variables. So those are the variables here in the shader. So we need background color, foreground color, and level depth. We'll use the set shader material method that shader materials come from. And the string, the first string, is going to be the name of the uniform variable on that shader. So for example, foreground color. And then we're going to pass it our foreground color variable within our level. And we'll do the same thing for the background color. And we'll do the same thing for the level depth. So what we're doing is we're passing our levels. Looks like we have some errors here. Oh, I didn't finish writing this stuff. Okay, foreground, background, color, and level depth. And here we're going to pass it our map depth. And it's pretty obvious we're going to have to pass it the map depth times 2, right? Because even though we pass it 11, for example, the depth of the level on the z-axis is 22 units. Okay, let's make sure we don't have any errors. What we're doing is it's taking this green and then it's passing it to this shader parameter, this uniform variable. In this case, this one's the level depth, 22, which it received. So now, if we go to our level and we change for example, let's change the depth of the level, and it should work. And it is, and that's beautiful. And the cool thing here is because we're manipulating the shader itself, we don't actually need to do anything with the obstacles. All the obstacles are using that shader, and we update it once when we generate the level, and all the obstacles will use that shader. So we are done here. This is actually just doing the exact same thing we were doing before, but now we're doing it with a shader, which is kind of cool. A lot of neat options available to us. Hope you're enjoying the show. I'll see you next time.